Hi everyone. So we last time we met, we were talking about cumulative frequency, and we said this is the frequency which actually accumulates. So you keep adding. So if this is the table that we looked at. So if you have this table, distance 0 to 20, there is two here, and 20 to 40 there is 3, 40 to 60 there is 9. So when we want to do cumulative frequency, we actually add frequencies at each stage. So the first one is 2. There it is, it's a 2. And then we next do 2 plus 3, and therefore this becomes a 5. And then we do 2 plus 3 plus 9, because it's 2 plus 3 plus 9, we get 14. The next will be this 14 plus this 5, so it gives 19. Then the next will be this 19 plus this one. Here it will give 20. So we said this is cumulative frequency. Okay, cumulative frequency. So cumulative frequency here, 2, 5, 14, 19, and 20. These will be on the y-axis. And then we have the x-axis, which will have the upper bound of the distance. Distance is 0 to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100. So we're going to only get the upper bounds. This is how we do our cumulative frequency curve. So this is what we are going to plot now. 20 versus 2, 40 versus 5, and so on. So we already talked about this, and we plotted, and our curve, our smooth curve, comes out like that. Okay, so this is the smooth curve that we have. Now, there are certain things we can do on this graph. The first thing is to find the median. So we said when you are given, when your cumulative frequency comes to 20, then your median is at 10. All right. So median is 10 because it's half of 20. So you have 10. And then, so you read there across. When you hit the curve, you go down and get the number that shows down there. And the median in this case is 51. We went ahead to talk about the lower and the upper quartiles. We said the lower quartile is the 25% of the data, the first quarter. Okay, so it's a quarter of the cumulative frequency, which is the 25% of it. So we have 20 divided by 4 because it is the quarter of it. So 20 divided by 4 gives us 5. So we go to 5. Right. So we go to 5. We hit the curve, go down, it gives us 40. So lower quarter is 40. Then the upper quarter, we said, is the 75%, which is 3/4 of the data. And so 20 times 3/4 is 15. We go to 15, we go straight, hit the curve, come down, and the number we get there, 62, is the upper quartile. So we have the quartiles and the median. We said the lower quartile and the upper quartile are there, and the median is actually the middle quartile. Okay, sometimes we call it Q2. So lower quartile will be Q1, median will be Q2, and upper quartile will be Q3. Okay, then we also have what is called the interquartile range. So we are finding the interquartile range. The interquartile range is basically the difference between the upper quartile and the lower quartile. So if you want to find that difference, look below here. Okay, the interquartile range is the distance between 62, which we got for the upper quartile, and 40, which we get for the lower quartile. Subtract them, then you get 22. This is the interquartile range. It's also called IQR. IQR, interquartile range. All right, there we go. Those quartiles can also, we can also find percentages. For example, so a percentile is a percentage. So the 675th percentile is actually 75% of the data. So the third quartile, which we call Q3, which is the upper quartile, okay, is 75%, the value that is found at the 75th percentage point. So we call it a percentile. So which means for percentiles, you can even be asked to find the 10th percentile, and that will just be at 10%. So you find 10% of the data. Or if you have asked to find the 50th percentile, it means it's the median. It's 50% of the data. You can be asked to find the 25th percentile. It's 25%, which is quarter of the data. You can be asked to find any percentage. So you just need to get that percentage, work out from the cumulative frequency, and then get the value. Okay, so those are percentiles. Percentiles are just percentages of the cumulative frequency. Let's go to histograms. Histograms are like bar charts, except they use continuous data. Now, continuous data is what we've already experienced. Okay, now let's look at a histogram in specifically now. In a histogram, the area of each bar is proportional to the frequency. The area of each bar. So a bar. So there will be a bar. The area of that bar is the frequency of that bar, which is represented by that bar, the frequency. All right. Now then, if the area of the bar is the frequency, then the y-axis, which is always the frequency, will not be the frequency anymore. Okay, the x-axis will continue being what it has always been, but the y-axis will change. Now you may not have understood this, but look at the next thing. The bars can have different widths. Okay, so in a histogram, you remember in a bar chart, the bars all look the same in terms of the width. This bar and the next, they all are the same width. But when we come to a histogram, some bars will be bigger than others. And then the y-axis will be called frequency density, which you may not have understood right now, but let me just show you something which is drawn. Firstly, let me say frequency density, which will be on the y-axis. Frequency density, which will be on the y-axis, because remember the y-axis you're supposed to put frequency. Y-axis should be frequency, but now y-axis will be frequency density. So the frequency density, which will be on the y-axis, is calculated by getting the frequency, then divide with the class width. Now, where do we get these things from? Okay, that is just a formula, but let me show you how this is happening. This is what we have for the data. We know this already. We know that data can be like this because this is continuous data. From 0 to 3, we have 6 phone calls, which took 0 to 3 minutes to just under 3 minutes. And then 3 minutes to just under 5 minutes, it's 7 phone calls. Then 5 to 10, it's 7 phone calls. Now, this we know. We can even do a cumulative frequency curve. But how do we do a histogram? So to do a histogram, we have to find the frequency density. So we have to add a column to this so that we solve frequency density. So we put a column here which is called class width. What is class width? Class width is how long is that? How what is the length of this? From 0 to 3. Okay, so you just do 3 minus 0. That length is 3. Then here you do 5 minus 3. That is 2. Then here you do 10 minus 5. That is 5. This is the class width. You need it to calculate the frequency density called the FD. All right, now there is the frequency density. So the frequency density, we do frequency over class width. So 6 divided by 3. That's the formula we saw. Okay. Here we do 7 divided by 2. We get 3.5. Here we get 7 divided by 5. Remember, it came from this formula here, right here. Frequency density is equal to frequency over class width. So we get that here. Frequency 6 over class width 3, we get a 2. So this will be the y-axis, while this length will be on the x-axis. So I have an x-axis with the class width, and then we're going to have the y-axis, which has frequency density, and you've seen how to work it out. So we do a histogram. Here is the frequency density. Here is now these timings. So we can see this is 0 to 10. So we just demarcate it in any way you want. This is 0, then 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9, then 10. So we have 0 up to 10. So we're going to now plot 0 to 3 versus 2. There. So from 0 to 3, 3 is here. It will rise up to 2 on frequency density. You see there's 2 here. So the same applies to the next one. It will be 3 to 5. So you see 3 here to 5. But it rises to 7, to the frequency density is actually 3.5. So it rises to 3.5. And then the next. Can you see the widths are different? The first one has a slightly big width. This one is slim. Then this one has a big width because we are plotting, or we are actually the bars we are putting here are class width, or the length here, which is grouped, versus the frequency density. That's what we are doing. So this is a histogram. Let's do this histogram. First thing, class width. Okay, so we find from 0 to 2 is 2, from 2 to 8 is 6, from 8 to 10 is 2. Then what do we do next? FD, frequency density. We do 7 frequency divided by 2, we get 3.5. 24 divided by 6, and so on. Then we can draw it again. Put that, there it is. This is the histogram from this data. All right? And then, so this is how a histogram looks like. So let's go back to probability since we have looked at the histogram. Probability 3. What are we talking about here? We are talking about Venn diagrams or sets. So probability is to do with sets. So let's go quickly to this. In a survey, 25 students are asked if they like banana ice cream and if they like chocolate ice cream. So there is banana ice cream and there is chocolate ice cream, and it has been put already in a Venn diagram. So now there is a few questions that we will need to deal with. The first question is, a student is chosen at random. Find the probability that they like both banana and chocolate ice cream. So they like both banana. A student is chosen at random. How many students are there? 25. Okay, we are finding the probability that they like what? Banana and chocolate ice cream. It's these 8 in here who like both. These 8 students. Because these 6 students, they like banana, but they are not in the set for chocolate. So they like banana but not chocolate here. This is chocolate. These 9 students here only like chocolate. They don't like to be in this circle, which also has banana. So these 9, these 2 outside, they don't like either. So they don't like banana, they don't like chocolate. They are outside. There's 2. These 8, they like both. So this question A is asking us to get the probability of those who like both banana and chocolate. And there are 8 out of a total of 25 students. Okay, so we go 8 over 25. All right, next question. A student who likes chocolate ice cream is chosen at random. So now we are choosing from these who like chocolate. These are 17, 9 plus 8. These 17, they all like chocolate ice cream. Among them, a student is picked. So we know the denominator will be 17 because we are choosing from a set of 17. Okay? So we are choosing from a set of 17. So let's choose from the set of 17, this 17. What are we looking for? Find the probability that they also like banana ice cream. So we chose from here, from students who like chocolate. Let's find those who also like banana. How many are they? 8. So 8 only out of all these students who like chocolate. Only 8 are also found to the banana side. Only 8. These 9 have nothing to do with, they don't like banana. The 9 and 8, they both like chocolate, but 9 also like banana. So it says a student who likes chocolate ice cream. So from the entire chocolate set, we choose at random. So they are 17. Then we find the probability that they also like banana. So we get 8 like banana out of the 17 who like chocolate. So this would be 8 over 17 because it's this 8 over both 8 and 9. Yeah, hope it is clear. Another question, 2 students are chosen at random. So these 2 students are chosen from the entire set here because they didn't say 2 students are chosen from those who like what. They just said chosen at random. So it's from all the 25 students. Find the probability that they both like banana ice cream. Well, if we're going to choose 2 students here and both of them like ice cream, we are going to now say, when we select the first time, how many students are we going to get? How can we get a student who likes banana ice cream? So to get a student who likes banana ice cream here, this is clearly 8 plus 6. This is 14, okay, out of 25. So 2 students are chosen at random. Find the probability that they both like banana ice cream. So the first time we pick, it will be 14 out of 25. The second time we pick, it will be 13 out of 24 because we'll be picking these students from here. So, but now we are looking at the probability of both liking ice cream. So I mean both liking banana ice cream. So it should be B, B, isn't it? Liking banana ice cream and again liking banana ice cream. So it should be from this set here. So liking banana ice cream, 14 out of 25, then 13 out of 24. Okay, then that is the total 91 out of 300 from the sets. There's another question D. Okay, did you see this? So 91 over 300. Then there's another one. Two students are chosen at random. Find the probability that only one of the students likes banana ice cream. Now remember from the tree diagram, this is the same question. Two students are chosen at random. Find the probability that only one. So two students are chosen. Only one of them likes banana ice cream. So it could be the first one doesn't like banana ice cream. The second one likes it. Or the first one likes it, the second. So there are two ways of getting. Uh, on the tree diagram, we are drawing branches. So it would be banana up, chocolate down. So that one who likes banana and likes chocolate, that is the branch that we need. But we can also have the branch that starts with chocolate, then becomes banana. So there are two ways of getting these students. We want out of two students, one to like banana, out of two. So it could be that when we are picking the two, it was the first student we picked who liked banana, then the second one didn't. Or it could be the opposite. The first one didn't like banana, while the second one did. So look at the probability. We have the two options. The first one is we could pick the one who likes banana is 14 out of 25 because it's 8 and 6. 14 out of 25, this student likes banana, times 11 over 24, this student who doesn't like banana. Those who don't like banana are actually 9 and 2, so it's 11. Okay, so it's liking banana times not liking banana because that's one branch, liking banana, not liking banana. The second way is to pick first a student who doesn't like banana. Then the second time is when you pick the one who likes. So it will be 11 over 25 times 14 over 24. Now, these are, remember, they are all situations. On a tree diagram, this one will be a branch joining this one. It will be a branch and a branch. Then this one will be another branch, a branch and a branch. It's also joining. So for these to be put together, since they're on different branches, it's or. Remember what we discussed across? It's or. This is why we are adding that. So I have to add. So here it says first student likes banana and second student does not like. Here it says first student does not like banana, while second student does. So you have to add that to get this again. It's a similar answer. Please practice this. We'll talk more when we meet. We have to go to stem and leaf. Stem and leaf diagrams, you have done this before, so it's just an overview. When you have data like this is just data. For this test scores of 20 students, this one scored 56, 13, 32, 36. They all have results here. We want to draw a stem and leaf diagram to group this data without losing any of the original details. So we don't want to group them so that we lose the details. We want it to be like that. Now remember, when we are doing a stem and leaf diagram, we have a trunk and then we have the branches on the side. Okay, so we are going to decide how to show this data. So for example, there's an example here, this one now that I'm showing, this one, this one, this one. So we're going to decide to say, okay, since they are all two-digit numbers, 5 would be the trunk, 6 would be the branch. So we are going to put a line in between 5 and 6 like that to say 5 is the trunk, 6 is the number. Now, let me show this already on here. It will be like this. We'll see that all the first numbers, there's 5 here, there's 1 here, there's 3 here. So all the first numbers rank from 1, the highest is 5. So we can put them on the left side of this trunk. 1, 2, 3, 4, 5. We will not just put them at random, we'll order them. 1, 2, 3, 4, 5. Then when we put this one, then we check which is the smallest one we have. It's 3. So we get this 3, we put it this side, like this. Okay, we start with the first number. So 56, we start with the first number. 5, then 6 is here. Then 1 and 3. Okay, and then 3 and 2, 3 and 6, So we are putting each one, but how are we putting? We are putting only the trunk, the right, the left, the right number. The left is the trunk. So we're putting them like this, and we're putting them some kind of in order, isn't it? So we're putting each one, each one, each one. So this is a stem and leaf. Yeah. So we've decided to put the 10, this number, the first number, the 5, the 3, the 1, the 2, the 3, the 4, the 3. These numbers are the trunk. Then we start now putting the the ones in the ones, like the 6 here, the 3 here, the 2 here, the 6 here. We started lining them up. So there we go. So then we also write a key. You cannot do a stem and leaf diagram without putting its key. The key is supposed to be there. There is a mark for the key because the key explains what did you do. So you write key 5/6, or 5 with a bar, and 6 represents a score of 56. So this 4 and 7 is 47. This 4 and 0 means 40. So you have put it. Okay, so the data is here, though it's not in order, but the trunk is in order. These numbers can be ordered later. So this is an unordered stem and leaf. Then there's also an ordered stem and leaf. Okay, so yeah, this is just the same thing. The leaves are then written in order to give the final stem and leaf diagram. So look at this. The final one, which is ordered, here it is. You see, small number 3, then 6, then 7, 4, 4, 4, 9, 2, 4, 6. No, now it's in order, isn't it? So now it's in order, right? Okay, what about if the data was like this? You can decide. It's you to decide, really. You may say, okay, let me put the first number, which is non-decimal, the 12 and the 11, the 10 and the 13, the 11 and the 11 in the trunk. Then these decimal, the first decimal place which we have, then can be the branches. So you could do like this: 10, 11, 12, 13 for all these numbers. Then now you populate your branches. Okay. So after you populate your branches, then you order it. So the first one was unordered. This was just rough. Then now ordered. You can put your ordered now. So then you order it. Oh wow. Then you order it. So 10, 1 represents. Remember, there is a key always. The key is 1 mark. So you have it. All right. So that's it. Then there's an example here. The stem and leaf diagram shows the test scores of 14 students. Find the range. The range will be highest minus lowest. Lowest here is what? According to the stem and leaf, 12 is the lowest, 42 is the highest. So you can find the range there. 33. Find the model score. Which one is the most repetitive number here? Which one is repeating the most? So you say, okay, most common score, it's 21, 21. Don't put 1, 1, please. This is 2, 1. There's a stem. Okay. So the median now, you have to count how many they are and divide. You know how to find the median. These are 14. So 14 will give you 7 this side and 7 this side. So it's between the two sevens. We discussed this thing. So if you want to just say 14 plus 1 divided by 2, the answer you get will mean, like, this is the 7.5th value. Okay, so you have to go there. It's 7 and 9. Just find a way of working that out. You find it will be between 7 and 9. So you add them and divide. So the answer is 28, between 27 and 29. Great, isn't it? Then we have the and whisker. So the box and whisker plots. This is a new thing, I think, to you guys. So the box and whisker plot. Um, in a box and whisker plot, the median and quartiles are shown together with the smallest data item and the greatest. So what we need for a box and whisker? Upper quartile. Okay, so we need the upper quartile. We need the median, we need the lower quarter, we need the lowest value, the smallest value, and the highest value. They are going to show. Now, how do we show them? Here now, let's say we have been given this, okay? Shortest time, 2. Lower quarter, 11. Median, 15. Upper quarter, 22. Longer. This is just data we have been given here, just to demonstrate how to show this data on a box and whisker. This data is given because it's a question. Let's say this is a question and we were given the data. So how do we show this data on a box and whisker? That's the question. So we go. We first get a ruler. So you'll be given space on the question paper. You put a ruler. Now you check the data. This data is like starting from about 2 up to about 37. So it is kind of reasonable to start 0 to 40 because you have 2, you will need 37. The others will be in the middle. So just look at the shortest and the longest. Accommodate them. In this case, 0 here and 40. Just draw a line, just an x-axis. Don't put any y-axis. Just the x-axis, which is just a line, and put equal demarcations. Then start plotting them. So you start. 2 is here. You see a mark has come for 2. Then you put 11. 11 is just above 10 here. There, you put it a longer one. You will know why later. Then the median is 15. So you put at 15. Then 22. 22 is just after 22. 2 boxes after 20. Then 37. 37 is here. Then you join them like this. Huh. This is a box and whiskers. This is a whisker. This is a whisker. This is a box and so I have whiskers and a box and whiskers. So there's a box in between and whiskers on both ends. So what is the box? The box has the median in the middle. It has the lower quarter on the left. It has the upper quarter on the right, and you draw the box. The whiskers is the lowest value and the highest value, and you join them with a line. Okay, that's why we made these lines a bit shorter, but doesn't matter. I can make them long. There is no loss of marks. And then there's another whisker here, which is the highest and